Hello, my name is Henrique Zaparoli. I'm a master's degree student in a São Paulo State University in Bauru, and it's a pleasure to present my work at the first Symposium Nanotechnology for Research and Biomedical Application. My work entitled Potential Photosensitizing Agent in Photodynamic Therapy from the green synthesis of zinc oxide nanoparticles. The focus on advancement and field of material science, seeking new technique and application of nanotechnology and synthesis of nanomaterials for the detection, diagnosis, therapy, and the fight against cancer. Among the different nanoparticles, zinc oxide (ZNO) stand out due to their application and unique properties, especially their sensitive of ultraviolet radiation, and with the oxide can transfer electrons from the valence band to the conduction band, giving rise to an electron roll pair that can generate in the presence of water or molecular oxygen reactive oxygen species. Given said, this study aimed to produce zinc oxide nanoparticles by a green chemistry approach, sent out for using less toxic productions, resulting in a poor bioproduction. Using a new precursor of glycine MOX and its use of photosensitizing and photodynamic therapy. Initially, the extract was prepared for glycine MOX scenes by a filtration process. The synthesis route used was microwave-assisted hydrothermal, and with the potential of three different precursors was tested: zinc acetate, zinc chloride, and zinc nitrate. Each precursor was mixed with urea and molar concentration of 1 to 3, and equal volumes at ethylene glycol and soil extract were added. After magnetic screening, the solution was transferred to Teflon tubes and placed in a microwave digester with a 10-minute ramp until reaching the temperature of 100 degrees Celsius. After 20 minutes, the precipitator was collected, centrifugated, and washed several times with milky water and acetone. Finally, keep the powder was dried, keep in the oven at 100 degrees Celsius for 12 hours, and in a muffler to 2 hours at 100 degrees Celsius. For the characterization of the nanoparticle, X-ray diffraction, scan electron microscopy, and UV spectroscopy were used. And for production of ROS, potential was keeping indirectly use its solution of nanomaterials with DPBF proof. Through to the physical characterization techniques, we observed the formation of hexagonal structure in the word-side face for the tree synthesis by UV spectrometry. We observed the characterization band of ZNO around 317 nanometers, and morphology of materials by the scanning electron microscope technique, resulting in a clusters of nanoparticles. Through the photobiophysical characterization, we verified that the solution contained only DPBF F19 seconds of radiation of UVA light. There was reduction of initial to and final absorption band by 25% in the DPVF solution, with the addition of each solution of nanoparticles made with zinc acetate, zinc chloride, and zinc nitrate. We observed a peak absorption reduction of 21%, 22%, and 20% respectively. These preliminary results indicated the formation of zinc oxide nanoparticles by the green microwave-assisted hydrothermal route, as well as the initial test of photobiophysics present promising condition of potential use for the application of these nanoparticles as photosynthesizer of use in photodynamic therapy. These were the result of my work. Thank you for your attention.